So if I wanted to graph the following, I would just kind of draw myself a little number line. I don't know, maybe have 0, have 4. Being that we don't have a little tiny line underneath the inequality sign, that means it's going to be an open dot, and we want values bigger. Okay? Now, that's graphically. If I wanted to put it in something called interval notation, interval notation would say, hey, we're going to go from 4, and we're going forever to the right. Forever to the right would be infinity. So we have a rounded bracket. The rounded bracket means it would be an open dot. There wasn't an equal sign there. Okay? Problem number 2 says I want values that are less than or equal to -2. So we're going more negative. So if I drew a little number line for number 2, I had 0 here, I have -2 down here. I would have a solid dot on this one because I have the equal sign, and I want values less. Now, friends, where is that arrow pointing to? It's pointing to the left. What's left on the number line? Negative infinity. Very good. So if I were to write this as interval notation, I read interval notation from left to right. So it's coming from negative infinity. It's going to -2. And we're going to put a hard bracket because we had that equal sign, because it was a solid dot. Questions for me on that so far? All right, problem number 3. I want values that are less than 0. Okay, I don't want values equal to 0. I want less than 0, so it's going to be an open dot going to negative infinity. And again, if I did my interval notation, it's going to go from negative infinity to 0. 0 has a parenthesis or a soft bracket because we didn't have an equal sign with this. Problem number 4, I want values greater than or equal to -10. So if -10's down here, 0's somewhere in this region to the right of it. So I want equal to, so it's going to be a solid dot. Solid dot because we have that equal sign. And we're going to go to the right. And if we go to the right, we're going to infinity. If I wanted to write that in interval notation, I'm going to do a hard bracket at -10 because we had an equal sign, because we had a solid dot. And we're going to go to infinity. Okay, so the interval notation is a mathematical interpretation of what's happening on the number line. Friends, do we have any questions about that? Everyone feel okay? Where did I lose you?
Wait, what?
You're shaking your head no, and I was like, oh no.
Oh, I'm not even thinking.
Oh, okay. Pull your mask up though.
I might not if I have it on it.
Huh?
I might not have a disease called can't wear mastitis.
Yeah, I run a medical class, and I've seen about 700 different presentations over the past 15 years. I've never heard of that disease.
Yeah, this is the 701st.
Okay. All right. I'm going to move up, down below. All right, so as we move it down below, let's take a look at this. This looks a little bit different. So if we think on a number line, if I have a -2 here, maybe I have a 0 here, maybe I have a 4 here. When it's grouped together like this, I usually look at the very last thing and say, oh, okay, it's an open dot. And then I look at this one, I have an open dot. So I have in between both of those. Okay? The interval notation with this is actually going to look like an ordered pair. But it's not an ordered pair. It's not a point. This is interval notation. Okay? They're both soft brackets because we didn't have an equal sign. And we were talking about the region in between the two. Yeah.
So you're saying that x could be anywhere between -2 and 4?
Uh-huh. So it could be -1, 0, 1, 2, 3, or whatever decimals or fractions are there. All right. Next one, I'm going to go from 0 to 10, it looks like. And again, I'm going to look here. So that's telling me to go this way. Then I look here. So that's going to be a solid dot. The reason there's a solid dot is there is an equal sign. So I want the region in between those. So interval notation says read it left to right. Well, being I have a solid dot, I'm going to have a hard bracket at the 0. And I'm going to have a soft bracket at the 10. Again, that's the interval notation for that particular problem. Roger Dodger, did you have all those on there? I can't remember. No? Okay. No? Okay. So I gave you a bonus. So bonus problems. Yay. All right, friends, may I move on forward to another page? Key, you good? Almost? Okay, sure. All right, so again, we're going to talk about the interval notation. Now, we just talked about this a little bit. It's okay if we have a number line, but I'm looking for values that are bigger than 4. So I'm going to have a soft bracket at 4 because I don't have an equal sign, and I'm going to go to infinity. Okay, I want values bigger than 4. Bigger than 4 goes to infinity. This one, I want values that are less than -2, so more negative. So that's going from negative infinity. Infinities always have a parenthesis because I can't get there. But then I go to -2. Will -2 have a square bracket or a round bracket? Square. Why is that? Yeah, you have that equal sign, so it's going to be a hard bracket, they refer to it a lot of times. Let's see. I want values less than 0. Well, that's to negative infinity. And it's a soft bracket at the 0 because there's not an equal sign. So again, the interval notation is how you would read what's going on. It's a mathematical representation symbolically of what's going on with our graph. For this one, I'm going to go from -10. What kind of bracket's at -10? It's a square one. Why is it a square one? Because I got that equal sign right there. And it's going to the right. I want values bigger, so it's going all the way to infinity. Again, infinity always has a soft bracket. For number 5, I'm going from -2 to 4. It's a soft bracket on both because I don't have an equal sign. So we're talking about any of the numbers between -2 and 4 would work as this interpretation. And then the last one, hard bracket to 10, soft bracket because there's not an equal sign on the 10. Okay, now, interval notation is a different thought process. Okay, me going over a handful of examples probably is not going to have you mastered it yet, but we will start getting there, okay? But it's a matter of you attempting the assignment. Is this what your next slide looks like? I don't know. Yay? Okay. So write an inequality for each. Well, I want x is greater than -2. Okay? Why did I only use the greater than sign? Well, it was an open dot. So I guess if you wanted to, the interval notation would be rounded bracket -2 to infinity. Okay? This one, we want x is greater than or equal to -4. So the interval notation is a hard bracket from -4 to infinity. This one looks a little bit different. Let's think about this one. I want values that are less than 0. So we have to realize negative infinity is to the left. So read it left to right, the number line. Negative infinity to 0. 0 is a soft bracket because we didn't have a solid dot. Ready to move on? All right. So discrete or continuous? Discrete is like counting. If I wanted the discrete data in this class of how many kids are in this class, it doesn't matter if you're taller or shorter, missing a finger, missing an ear, whatever, you're still count as a person. So if someone came in and said 1, 2, 3, 4, so this is just counting. Okay? Continuous means it just keeps going up. Okay? So like temperature of a day. Like today might have had a low temperature of, say, 40 degrees, and it might have a high temperature of 80 degrees. But, if you watch the weather forecast, he's going to give the exact, the rounded up value of the temperatures. Hey, it's 61 degrees right now. Hey, it's 73 degrees right now. But if you think about temperature, is you use all the decimals and fractions in between. Okay, so temperature is a good thing. If you have really accurate, like a timepiece, you could go out to tenths of a second, hundreds of a second, thousandths, 10,000ths, 100,000ths. Okay, so when your clock is counting up time, yes, we might only go from 0 to 60 as far as seconds, and 0 to 60 as far as minutes in an hour, and 1 to 12 for the time. But time itself, unfortunately, we don't have an old clock that shows the second hand going around. But you have fractions of seconds that exist. So time could also be continuous data, though continuous can look like discrete because it depends on the accuracy of our stuff. So temperature of cooked chicken needs to be above 165 degrees. So it'd be something like that, okay, which means I'd go 165. Now, obviously, I'm not going to get to an infinite temperature. If we did that, the chicken's going to go away. But this would be continuous data. Again, because 165.1, 165.11, 165.111, 165.1111, we have all those temperatures. Though our temperature gauge might only read the next higher temperature, the temperature didn't go from 165 to 166 instantaneously. It had to build temperature from 165 to 166. Your bank account cannot go below $50 balance. Hey, can we have a negative balance in a bank account? Yeah, it's called an overdraft. Okay? Unfortunately, sometimes you might write a check or go to pay for something, and though your card will account for a certain amount, you can go negative. So your bank account can go from negative infinity to 50. Cannot go below this. So our bank account can't go below that. Okay? Money is discrete. Agreed? Even though we have pennies and dimes and quarters and nickels and half dollars, this is discrete. Okay, so it's a decimal amount that is definitely discrete. You can't ask your friend, hey, how much money you got in your wallet? I got $5, $5.2577378 in my pocket. How's that work? And someone says, man, you're out of control. All right, go ahead.
So, like, basically, because it has, like, concrete amounts you can calculate?
Yes.
Okay.
Yeah, that's a good idea. I like that. All right, to make the varsity team, you have to run the 100-meter dash in under 10 seconds.
11.
Or under 11 seconds. Thank you.
Under 10 is like a world record.
World record. 11's fast too, isn't it?
Yeah.
All right, so I guess technically you could go from 0 to 11 under. That's kind of funny to think about. So, are there really accurate timepieces? Yeah. So you have to realize time is always going to be continuous, but it might appear to be discrete depending upon how accurate your timepiece is. Okay? And then the number of people in an elevator cannot exceed 12. Well, I guess I could have 0 people in the elevator. I could have up to 12 people in the elevator and anything in between. Just because you bring a baby on board, it still counts as a person according to the elevator people. Okay, so we'd have 0 is less than or equal to x, which is less than or equal to 12. Being that you're talking about people, it's discrete. Again, it doesn't matter that someone's taller or shorter. They still count as a person. Is that it? That's it? I'm done with this stuff? Yeehaw. All right, so let's take a look what kind of opportunity we have for next time. Hey, you guys want a lot of homework tonight? Okay, we'll have like 19 pages. All right, what do we say? What do we say we do? Page 67, 68. Oh, I don't want to go that far. Let's do 1 through 19 odd. Hey, what do you know about odd problems in Mr. Stirrup's classroom? There is a video that is posted on Schoology. And Mr. Stirrup's voice is the person who is speaking.
Because none of the other math teachers want to do it.
They're like, why would we do that? I'm like, just because. I don't know. I think it's a good idea, but I might be wrong.
So you do the odds?
Yeah, I will. There's a folder under this page for CP Algebra 1. And if you go down, there's folders for each week, and then you'll see SLI odd answers. You go into SLI number 1, you click it. It's going to take you to a YouTube page. And it has all of the videos there for the odd answers worked out. Cool? All right, so just hit the odd.